In this video, we'll write the balanced net ionic equation for PbNO3 plus MgBr2. This is lead-2 nitrate, and this is magnesium bromide. First thing we need to do with net ionic equations, we need to balance the molecular equation. When I look at this, it's already balanced, so that's kind of nice. Next, we write the state for each substance. So nitrates are very soluble, so that's going to be AQ, dissolve in water. Bromides, soluble as well. But this lead bromide, as I recall, it's a bit of an exception. If you see a lead compound, it's probably a good idea to check. Let's take a look at the solubility table. So we have the positive ions here. Right here is lead at the bottom, and then the negative ions. So we're looking for the bromide ion, Br minus. So we go across, we can see that it's slightly soluble, just like lead chloride and lead fluoride. Slightly soluble, we treat that the same as insoluble when we do net ionic equations. And you can see most of these lead compounds are either slightly soluble or insoluble, with a few exceptions like lead nitrate or lead chlorate. So PbBr2, that's going to be insoluble, and since it's insoluble, it won't dissolve, it'll be a solid. It'll actually sink to the bottom of the test tube. This is a precipitation reaction. Nitrates, again, very soluble, AQ. So we have the states. Now we can split the strong electrolytes into their ions for the complete ionic equation. We don't know the charge on lead, but we do know the nitrate. The whole thing is 1 minus. That's a good one to know. So we have 2 times the 1 minus. This has to be 2 plus. So this is the lead 2 ion. I'll write the states later. We have 2 nitrate ions. And then we have the MgBr2, magnesium, that's in group 2 on the periodic table, so it has a 2 plus ionic charge, and the bromide ion is 1 minus. So the magnesium ion, and then we have 2 of these bromide ions. So these are the reactants in our net ionic equation. For the products, we don't split solids apart in net ionic equations, so we just have PbBr2, that stays together, then magnesium's 2 plus, that nitrate ion 1 minus. So the magnesium ion, Mg2 plus, just like in the reactants, plus 2 nitrate ions, also like the reactants. Now that we have everything broken down into ions, we can cross out spectator ions. They're on both sides of the complete ionic equation. They haven't changed. We're really not interested in them. Here are our reactants and our products. In the reactants, I have 2 nitrate ions. I also have that in the products. Get rid of that. Here's that magnesium ion, and in the products. Get rid of that. What's left, that's the net ionic equation for PbNO3 plus MgBr2. Let me clean it up, add the states. We'll have our net ionic equation. So this is the balanced net ionic equation for lead-2 nitrate plus magnesium bromide. You'll note that charge is balanced. We have 2 plus and then 2 times 1 minus. That's 2 minus and 2 plus. That gives us a net charge of 0 here in the reactants. This is a neutral compound, net charge of 0. If you count the atoms up, they'll be balanced as well. This is Dr. B with the balanced net ionic equation for lead-2 nitrate plus magnesium bromide. Thanks for watching.